Hello, it's 15-minute maths week 2. It's Monday, and here we go. 15 minutes of maths to boost your skills in mathematics. 10-week course, week 2. Here you go. We're used to this by now. There's the first 5 questions. Press pause. Have a good go at these, please. Some more questions. Only 10 questions today because some have multiple parts. So there's the next 2 questions. Pause, have a go at 6 and 7, and I'll move the camera out. I'll move this just a bit in a moment for you to do the other questions. And there we go, 8, 9, and 10 questions, but there's multiple parts, so I think 15 minutes for this is about right. Answers in just a moment. Have a good go at all the questions first, then check for answers. Okay, here we go. Let's have a go through these answers. 15-minute maths. Let's see how long it takes us. Bit of number work again today. Here we go. Some answers. Right. That number to the nearest million. I'll read it to you. It is 476,823,418. Correct to the nearest million. So there's 476 millions, but you can see that's the cutoff for millions there, right there. And the 6 is followed by an 8. And you should know if that digit following is a 5, 6, 7, 8, or 9, you round up. So it's not, that number is not closer to 476 million, it's closer to 477 million. So very well done if you got that one right. 477 million, that number to the nearest million. Number 2, a whole number is given as 421,000 to the nearest thousand. Write down the largest and the smallest possible values of the actual number. So the smallest possible value of that number could have been 420,500, because that 1,000 followed by a digit 5, the smallest digit, could have rounded up to 421,000. I'm presuming this is a whole number. Presuming it's a whole number, so the biggest whole number it could have been would be 421,499. If you wrote 421,500, even though that would round up to 422,000, if we were thinking of this being a decimal, that's the absolute limit. It can't be equal to that. But if you wrote that, I kind of get what you're saying. It should have said, oh, a whole number. It does say a whole number is given, a whole number. So yes, in terms of decimals, sometimes we think of it like that, but this is given as a whole number. Those are the biggest and smallest whole numbers that would round to 421,000. Very well done. Write these numbers in words. I'll just read them out to you. This one you should write as 34,002. Sometimes we miss out the and, that's okay. So 34,002, I suppose, but 34,002. Part B, you should have written 4.007. That doesn't sound quite right, does it? So we should have written 4 and 7 thousandths. 4 and 7 thousandths. If we think about our columns, after the decimals, these are units. What's next? These are tenths, hundredths, and in here we've got thousandths. Quite difficult to say. Thousandths. To get my teeth checked. 4.007. 4 and 7 thousandths. And this number, 600, and what column is this? What column is this one? This is our hundredths. So 600 and 200ths. Okay, so there we are. There's those answers. 34,002, 4 and 7 thousandths, and 600 and 200ths. I don't think I ever remember anyone ever asking me to say that. I would nearly just always say 4.007 and 600.02 in these cases, but there we go. Let's write these numbers in figures. Let's do a bit of an opposite. 42 million and 27,000. So 42 million is 42 followed by 6 zeros. But we also want 27 thousands. So 27 thousands. I want 27 thousands. So I'm going to need to change that to 27,000. So 42 million and 27 thousands. Well done if you got that one right. 462,000. So that would be 462,000. There we are. It's 462,000. Write these numbers in order with the smallest first. So we look at the tenths column first of all. The tenths column. This is the dominant value here, the tenths column. This is what will give us the biggest number to start with and the smallest number to start with. The smallest out of those tenths is 0.127, and there's another 0.19. So then, of course, we look when we've got something to figure out. I've got the 0.1s. It's either of these two, but the 9 in the hundredths is bigger than the 2 in the hundredths. So the smallest, reading from left to right, I'm going to write them, is that one, 0.127. I'll cross it out to remind myself that I've already used it. Next would be 0.1901. Now, let's look back to the tenths column again. There's 2 tenths, 7 tenths, 8 tenths, and 3 tenths. So back here, go back to the tenths, the dominant, the furthest left in the digits, I suppose, are the biggest digits in our number system. Then the next one, 0.32. Then we decide there, is it 0.72 or 0.81? 0.72 is less than 0.81. So very well done if you got that one right as well. Very good, well done. Next, let's have a look. If you haven't had a chance to go through these, pause the video again. If you have, here we go, decimal places. Let's have a reminder of decimal places. 3 decimal places. So that's 1, 2, 3 decimal places. And then there's a cutoff there. Now that 9 is followed by a 5. So I have to round up a 9 to a 10. 9 to a 10. I can't write a 10 there, which rounds that 9 up, which also rounds that 7 up. So our answer is 4.800. Don't forget to write the second and third decimal places even when there's 0. So a very tricky question, that one there. Rounding up there, the 9 rounds up, and that digit changes. And 700, you can think of it like this: 799 is rounded up to 800, that type of thing. Similar way of thinking. But yes, 4.7995 is very close to 4.800. 2 decimal places, 2 decimal places. There's the 2 decimal place cut off. The second decimal place is followed by a 6, so it rounds up. So that's 0.01. The 0 rounds up to a 1. 3 decimal places is cut off there. Okay, so the 7 is followed by a 9, so it rounds to an 8. So 0.0138. Now I think the hardest one was the first part there, where you have to kind of take that 5 and round up the 9, round up the 9, round up the 7. So the trickiest one. If you got that one right, very, very, very well done if you got that one right. A bit tricky, that one. Write these numbers in figures. 7 thousandths. Up above, I mentioned this already, but yeah, people do find in high school sometimes a bit tricky are columns. So let's have our units, our tenths, our hundredths. In there are, maybe I'll just go back and space this out a little bit better, shall I? Let's have a think if I can do this a different way to give us a bit more space. All thousandths and the hundreds, so I don't need that many spaces, do I? Let's have a look there. That can be my tenths, there'll be my hundredths, and there'll be my thousandths. We'll go one more. So these would be, maybe I should just change my stroke thickness to help you out a little bit. This is my units. There we go. These would be my tenths. These would be my hundredths. Just to top the D off. These would be my thousandths. These would be my tens of thousandths there. Okay, so I think that helps a little. Let's see. 7 thousandths. So that's 7 in the thousandths. Doesn't say anything else, so no units, no tenths, no hundredths. I don't need to bother writing anything down here. There's nothing there either. So that answer would be 0.007. 48 thousandths. So let's rub that out. 48 thousandths. Let's have a look. 48 thousandths. If you ever get stuck, just do this. Do what I've done here. It really does help. Now, a bit trickier. 48 thousandths. So I want to write 48 thousandths. That's how we write them. 48 thousandths. 48 thousandths. Just like that. Happens to have 4 in the hundredths column, but that's how you read it. 48 thousandths. There's none of the tenths, none of the units in this case, so 0.048. 29 hundredths. Let's go for that one. 29 hundredths. Let's go back to drawing. 29 hundredths. 29 hundredths. 29 hundredths. There you go. 0.29. Lovely. Very well done if you got those. And yes, use this little technique of scribbling, not scribbling, that's the wrong word, but quickly drawing out some columns if you need to. Excuse me. Last three. What is the largest number that you can make using these digits? I love these questions. The largest, if you think about it, the way our columns work in mathematics, the biggest values will be further left. You know, you've got the millions right up there on the left, the billions even further, the units kind of just to the left of the decimal place. So we want to put the largest digit possible on the left. So that would be 9. Then the next largest digit, 7. Then the next largest digit, 4. Then the next largest, 2, and then 1. So 97,421. Yes, if you were asked for the smallest whole number you could find, you could just do the opposite. You'd write 1, 2, 4, 7, 9. But we've been asked for the largest. The smallest number you could make, of course, is 0.000. But if we were in whole numbers, but anyway, that's the largest number you can make. And there's no zeros to use, so I can't make any bigger than that. Number 9. The number is given to Sarah. No, a number is given to Sarah as 4.2 correct to 1 decimal place. The original number, it had 2 digits to the right of the decimal point, so it had tenths and hundredths. Write out the possible values of the original number. Okay, so we're looking for numbers that would round to 4.2, but they must have 2 decimal places, so 4.2 something. If it rounds to 4.2 to 1, so this has got to be less than 5, hasn't it, this number here? So it could be 4.21, it could be 4.22, it could be 4.23, 4.24. That would all round to 4.2 to 1 decimal place. If you go to 4.25, you suddenly, oh no, hang on a minute, that's followed by a 5 now. That would round to 4.3. So I'm going to leave it there and cross it out just to remind ourselves. That's quite a nice thing to do. And you might think, oh, that's it, done. You've missed a whole bunch of answers because you could have had 4.200 is a digit. Yeah, it's 4.20 would, if it was 2 decimal places, round to 4.2 to 1 decimal place. You may have also forgotten 4.19. Yes, that's a 2-digit number. Sorry, a 2 decimal place number. 2 decimal place number. The 9 would round that to 4.2. And of course, once you realize you've got all this bunch as well, haven't you? 4.17. You've also got 4.16 and 4.15, because if a 5 follows 5 or bigger, it rounds it up. So you may have got half of those and not the other half, depending on how your mind was thinking about how that rounding works. If it's 5 or bigger, you may have got 4.15, 4.16, 4.17, all of these, and forgotten these ones, or you may have done these ones and forgotten the other ones. But there's a whole bunch of numbers. How many out of interest? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 10. 10. That's interesting. Yes, of course, our number system is based on 10, so no surprise really that there are 10 2 decimal place numbers that would round to 4.2 to 1 decimal place. Okay, so very well done if you got all of those. And if, I should have said, you could have had 4.14 there and disqualified it like that to make sure. In maths, it's great sometimes to do that, to find the limit of your answers and cross it out so you know you've got every one of them. So very, very well done if you did that. Is this statement true or false? This means greater than, doesn't it? Well, actually, a bit of maths here. In primary school, you might say, well, that means greater than. Well, it depends which way around you read it. In high school, if we read it this way, it means this number is greater than this number. But if we read it around this way, it means this number is less than this number. So a little bit of difference sometimes there in primary school maths and high school maths. That sign is not ever strictly greater than. If I read it one way, it can be, for instance, I'll just show you now. 7 is greater than 3. 3, I just read 2. 7 is greater than 2. But if we read it from the right to the left, 2 is less than 7. So it depends which way around you read it. 7 is greater than 2, 2 is less than 7. Whichever way, the smaller of the two numbers goes at the pointy bit, and the bigger goes at the open widey bit. And you may have done all kinds of crocodile eating numbers and all that kind of stuff in primary school, but that is the way it works. A bit different maybe there for high school maths. Anyway, let's go back to the question. Which is it, true or false? They've both got 3 in the tenths digit. That doesn't help me. But in the hundredths digit, there's a 1 here and a 0 here. This 7 is not going to come into play at all. So 3 in the tenths, but look, 1 is a bigger value than the 0. This is the bigger number. This is the bigger number. This is bigger. Okay, if you're a bit confused by that, let's just quickly put them both in our table. We've got 0.307, 0.31. We read, these are the biggest digits here on the left. These are the biggest. So let's read across on the left. They're both 0 in the units. They're both 3 in the tenths. The next biggest digit, the next biggest column, the hundredths. Look now, which is the bigger of the two numbers? This one. This is bigger. So this number is bigger as soon as you get that. So it's bigger. So this is absolutely false. Thank you very much for watching 15 minutes of maths. That's Monday out the way. And very well done to you if you stuck through that. This is week 2 of a 10-week course. Stick with it. Stick with it. Try and time yourself, see how you do, check your answers. More of this to come through the week. We're going to stick with this kind of decimals and rounding and stick with that for week 2. Get you ready for high school. Thank you very much. See you soon. Don't forget to click, like, subscribe, that kind of thing, because that does help me track what is going on. Thank you. Bye-bye.